When specifying the clutcher system, there are several important considerations to keep in mind. Where conventional suspension systems are typically over-specified, steel cable systems tend to be more closely specified against the design load and can be overstressed if improperly designed or incorrectly installed. Typically, a duct run is attached to some rigid object at one or both ends of the run. But some layouts force sections of a duct to stand freely, which could cause lateral swinging. Examples of such a layout include a duct that is cantilevered outward and only anchored at one end, the freestanding center of a long duct, or a 90-degree angle of duct only anchored at the ends. One of the advantages of using a steel cable system over traditional methods is its versatility in hanging configurations and designs. A risk assessment and design review should always be undertaken to gauge the hazards posed by the suspended load. The finished design must take into account all important variables, including what systems could fail, what are the potential causes of failure, and what are the consequences of failure. Ductmate recommends using one of 4 hanging configurations when using the clutcher system. Consider the amount of support the building structure provides. Then choose the appropriate configuration method that best ensures the prevention of lateral movement. Whichever specified system is decided upon, it should always be fitted with the appropriate number and size of clutchers. The first configuration is the single-point saddle. This method is the primary hanging method when using the clutcher mechanism. The steel cable is looped through an eye bolt that is attached to the top support and then secured with a clutcher. The same cable is then looped around the duct and back through the same eye bolt, then secured with a second clutcher. This method ensures that the working load limit of the clutcher is not adversely affected when a larger duct is used. The second configuration is the standard horseshoe. Using this method, the steel cable is looped around the upper support and secured with a clutcher mechanism at a 90-degree angle. The cable is then routed under the ductwork and back up to the upper support to be secured, again at a 90-degree angle, with another clutcher mechanism. This configuration is ideal for general-purpose hanging and can eliminate some swinging of the ductwork. When supported in this fashion, the tension in the steel cable is reduced by half. This mechanical advantage is the same concept that makes a block and tackle work. The third configuration is the spread horseshoe. Similar to the standard horseshoe, the spread horseshoe method can be used for additional stability. By spreading the points of contact of the steel cables to the side, the spread horseshoe creates a measure of cross-bracing. When supporting ductwork using the spread horseshoe configuration, increasing the angle of the wire from vertical increases the stress on the Ductmate clutcher system and reduces its working load limit. The system should never be used in a configuration which exceeds 60 degrees from vertical. However, since there are 2 steel cables, the total working load limit of this configuration is no less than the load limit of a single steel cable using a standard loop configuration. The final configuration is the standard loop. The steel cable is looped around the upper support and secured with a clutcher mechanism, then looped around the duct and secured with another clutcher mechanism. The standard loop configuration is suitable for applications where the duct will not experience lateral forces or be prone to swinging. The advantage of this method is its simplicity. This configuration can be used for general-purpose hanging and is recommended for duct diameters up to and including 18 inches. In an application where movement is not expected, the single-point saddle method, the standard horseshoe method, and the standard loop may be used. No matter the configuration or weight of duct you need to hang, a 3-inch tail of steel cable must be left outside the mechanism. Each clutcher is manufactured with a 5-to-1 safety factor, designed to protect the system against a temporary increase in weight load. The working load limit should not be exceeded during operation. During installation, contractors should ensure all clutchers are fully engaged and the load is suspended evenly from all of the attachment points. Failure to do so can drastically overload a single clutcher, possibly causing it to fail. When making adjustments post-installation, the load should be supported by other means before attempting to adjust the clutcher mechanism. The clutcher system should only be used with static loads, never for lifting or with oscillating loads. The clutcher system should also never be used in corrosive environments like pools or near oceans. These conditions may cause the metal to corrode and fail over time. After the clutcher system is installed, paint, oil, or any other substances that could affect the mechanism should not be applied. A final inspection of the duct system and hanging configuration should be completed by the installing contractor after all other trades have completed their work to verify that the integrity of the system has not been compromised.